Hello everyone. Today we are going to see the concept that is virtual ground in operational amplifier. So here the virtual ground is applicable in operational amplifier only when it is operated in closed loop configuration. Okay. So for the op amp that is operated in closed loop configuration itself, the virtual ground is applicable. In open loop, the virtual ground concept is not applicable in operational amplifier. Now let us consider the inverting configuration of closed loop op amp. Okay, now let us consider this circuit. Here we are calling it as an inverting configuration of op amp, means here the input voltage Vin is connected to the inverting terminal of op amp or the negative terminal of op amp. That's why it is called as the inverting configuration in op amp. Okay, here you can observe that the non-inverting terminal is connected to ground and the inverting terminal is connected to input signal. Here the virtual ground, it means that here the non-inverting terminal voltage is 0. So let us consider that the V1 and V2 are two node voltages in which the non-inverting potential is connected to ground, means the V1 value is 0. Here intentionally this inverting node voltage, that is V2, is approximately equal to V1 virtually. Okay, means here the V1 is 0. Okay, here in this configuration the V2 is always equal to 0. Virtually it is equal to 0. How it will happens when V2 is equal to V1, we are going to see in the upcoming slides. And also the most important point here is how the input current entering at the op amp terminals is 0. So in the upcoming concept we are going to see how the input current entering at op amp terminals is 0 and how the node voltages present at inverting terminal and the non-inverting terminal of op amp is equal to 0. Let us see how the input current entering at the terminals is equal to 0. Here if you consider the internal circuit of op amp in closed loop configuration, here some input impedance, here the node or potentials I have considered V1 and V2, that's why I have written the resistance is R12. Okay, so for an ideal op amp, if you consider the input impedance of an op amp is infinite, for practically its value is very high. Okay, so here if you consider, we know that the input impedance of an op amp is a high value and ideally its value is infinite. So from the circuit we can write the R12 equation as the input voltage Vd by I. So this equation we are obtaining from the Ohm's law. We know that from Ohm's law V is equal to IR. So from that R is equal to V by I. Here the Vd is the input potential. Here the input potential we have to consider for an op amp. If you observe that we are having two input terminals, so we have to consider the differential input voltage. Okay, so it is Vd by I. Since we know that from the definition the input impedance of op amp is infinite. Okay, so we can write the equation that is Vd by I equal to infinite. This equation is satisfied only when the denominator portion is 0, which means that if the current I is 0, then only this Vd by I ratio value is equal to infinite. From this we can say that the current entering at op amp terminals is 0. So from this above equation or from the concept of the input impedance of an op amp is infinite, ideally we can say that the current entering at op amp terminals is 0. Okay, this is the first point. And what is the second one? How these node voltages, which means that the inverting node potential and the non-inverting node potential are equal. If you consider from other definition, that is for an ideal op amp we know that the open loop gain is infinite. So now what is the open loop gain? from basic definition we can write gain is nothing but output voltage by input voltage. Now for an op amp, the output voltage is V0 and the input voltage is differential voltage, that is Vd. So V0 by Vd is infinite. We know that from the open loop configuration or from the closed loop configuration, the output voltage is always a non-zero value even if the input voltage is zero. So why the output voltage will present means because of this open loop gain. Okay, so see, we know that from an op amp the V0 value is a non-zero value. Some millivolts or microvolts signal is present at the output of an op amp even if the input signal is zero. Okay, so in order to satisfy this condition we have to maintain that the differential voltage, that is Vd, must be equal to 0. If Vd is 0, then we can say that V0 by 0, nothing but a non-zero value divided by 0 is equal to infinite. So from this we obtain the differential voltage is 0. So this differential voltage is nothing but the voltage present at inverting terminal and non-inverting terminal node voltages. So from the circuit we can say that Vd is nothing but difference of non-inverting potential and inverting potential, that is V1 minus V2 is equal to 0, implies V1 and V2 are same. Okay, so from this we can say that the node voltages at an op amp is always equal. Here the non-inverting potential is connected to ground, that's why here V1 is 0 and V2 is 0. For example, if this non-inverting potential is connected to some reference voltage, okay, let us consider some 10 volts. In that case, if V1 is connected to 10 volts, then V2 is intentionally connected to 10 volts. We are not connecting external voltage to this inverting terminal. Okay, so the overview of virtual ground concept in op amp is, the first point is, because of this high input impedance value that the op amp has, the current entering at the inverting terminal and non-inverting terminal is 0. And the second point is the node voltages, nothing but this is the node voltage that is present at inverting terminal and the node voltage present at non-inverting terminal is equal.